All right. I'm going to do one example for you on synthetic division. So Dr. Tom Pulaski and I worked on this about just a couple years ago. And synthetic division is similar to long division, but with polynomials. So what we're doing here is 3x to the fifth minus 4x to the fourth minus 5x to the third minus 8x plus 25 divided by x minus 2. So you set this up, and here's where the answer is going to be, just so you're aware. But what we do is we did a sample problem together, right? Dr. Pulaski and I did a sample problem of how this works. If you're not used to synthetic division, just so you know, how many times does x minus 2, right, go into, right, that the dividend? How many times does it go into here, into this divisor? So we're going to take this here, right? So I got my divisor, I'm going into the dividend, and I'm trying to think x times what equals 3x to the fifth. Well, it's an understanding of how to use the exponents in this one. So it'd be 3x to the fourth times x would equal 3x to the fifth. So 3x to the fourth times x, but 3x to the fourth times -2, right, is -6x to the fourth. Subtract, that would become 0. And then what's 4x to the fourth minus 6x to the fourth? If you're subtracting a negative, it will be 2x to the fourth. So what happens here? What's 2 times what equals 2x to the fourth? Well, 2 times 2x to the third. And we continue that same approach until we're left with something that doesn't divide clearly. That is my fraction answer. So this is just one way of collapsing that calculation to show you how synthetic division is done. And if you're thinking that sounds a lot like long division, that's the whole point. So these are the steps that Dr. Pulaski and I broke down. We set up the division by writing the divisor, right? We then set up by representing the terms of the dividend. We divide the first term of the divisor into the first term of the dividend. Then we complete the distribution, right, until we get to that second term, subtract. And even though we say bring down, it's really just what's the computation. We just wanted the same familiar language from long division to set up that synthetic division. But the truth is, it's really just what's remaining, right? What's the difference? We repeat those steps for all the remaining coefficients, right? All these remaining coefficients. And then the remaining term of the dividend that does not divide evenly into this divisor, that's the remainder. We can represent that as a fraction. Like in the example is 1 divided by x minus 2. So those are the steps that we came up with. That means instead of going through all those steps, I might look at what are some, because a lot of them are repeated steps. What are some of the needs here? Well, Euclid would struggle with computation of exponents. So what I need to do? Well, I'm going to prompt and provide examples for it. That means that was more teacher dependent. Take a look at this one. For computation of integers, Euclid and Newton still struggle with it. So I can do an independent one. They've had lessons on number lines in the past that will support Euclid and Newton's work on how to do the computation of integers required in that division approach. All right, so same approach you saw with the subtraction problem. What are the major skills? Who might need the support? And what will those supports be? And this is how the grading will end up coming, right? So you have your students' names here. They might be familiar to you. No, this is not their class. These are not even pseudonyms. These are just mathematicians. And so these are some of the needs, right? These are that we're doing here. These are the steps. And so under this step, the subtraction, you're going to highlight the number line for the 2 students who need it. And for the exponent work that I'll be checking, I provide, right, that prompting and examples to help support that student. Same approach. I hope you can take this approach and use it. Now, try some examples on your own for lessons and upcoming content outside of the examples we've shown here. But I hope that was helpful.